So in this video I will explain how to apply the Laplace transform of the given signals, and from that signals here I am taking one of the standard signal. That signal is rectangular function, right? So Laplace transform of rectangular signal. Laplace transform of rectangular signal. So to find to calculate the Laplace transform of rectangular signal, first of all we should know what is rectangular signal and what is the functional representation of the rectangular signal. So for that purpose, here I am explaining a rectangular signal. See, one function I am assuming here f of t. This is rectangular signal now, right? Rectangular signal, or it's also called as gate function. So from the signals and system we can write the name of this one is gate function. This is gate function. Now I want to draw the graphical representation of the gate signal. This is time axis, negative time axis. See, gate function or rectangular signal defined in particular time period with constant amplitude, right? So the shape of the signal is rectangular shape. Rectangular shape. So that purpose I am drawing like this. Here the signal is defined like this here. This side 0, this side 0. That means the signal is defined from minus t by 2 to plus t by 2 with amplitude A, right? Just observe the given signal. If the time is greater than the t by 2, the function is not defined 0. If the time is less than the minus t by 2, the function is not defined 0. But the signal is defined in particular time period. The time period is from, the time limits are from minus t by 2 to plus t by 2. Within this time period, how much amplitude is there? Constant amplitude. That amplitude is here A, right? So within these limits, constant amplitude is. So this type of signal is called rectangular function or rectangular signal. So here one discontinuity and another discontinuity is defined here, right? So at minus t by 2, exactly t is minus t by 2. At t is minus t by 2, the amplitude is changes from 0 to A, suddenly increases, and it maintains the constant amplitude up to t by 2 time period. And after t by 2 time period, so exactly at plus t by 2, the amplitude changes from plus A to 0. That means after this again the amplitude is 0. This signal is called rectangular signal. Now I want to write this complete rectangular signal in terms of functional representation. The functional representation I am writing like this: f of t, the given function is a constant amplitude function. A always explains the constant amplitude, right? So it's a constant amplitude. This amplitude is defined from, time is from minus t by 2 to plus t by 2. That's why you have to write like this: minus t by 2 to t and plus t by 2. So this is also one of the very important representation. So the given signal defined within this time period. And here what is t? Capital T. The capital T is time period of the signal. From here to here, the total time period is how much? Capital T. Small t explains the time variable. Capital T is a constant value, right? Capital T explains the time period. This time period is either 2 or 4 or 6 or 8 or 10, 11, 12, 13, any number we can take here, right? If suppose this time period is 4, now it is defined from minus 2 to plus 2, 4 by 2, 4 by 2. So minus 2 to plus 2. Just I am writing the standard function, right? So f of t is equal to A within this time period, and other than this time period, what is amplitude? 0. So f of t is equal to 0, otherwise means without this condition. So after this condition, so greater than the t by 2, less than the minus t by 2, the function amplitude is not defined, that is 0. So this is the functional representation of rectangular signal. And another standard representation also there. The representation is like this: f of t is equal to A into rect of t by capital T. This is also one of the functional representation of the rectangular signal. Here A explains the constant amplitude. A explains the constant amplitude. This amplitude is defined, time is from minus t by 2 to plus t by 2 with how much time period? T time period. So the t hut right here. Rect name explains it is a rectangular function. Sinusoidal function name explains the sine or cos. Similarly, the rectangular function name is explained with RECT, rect. So A into rect of t by capital T. This is also another functional representation of rectangular signal. Now I want to find the Laplace transform of this function. A rect of t by capital T. Right? So I want to find the Laplace transform of this function. To find this function purpose, here I want to apply different techniques here. So one technique I want to apply here properties. I want to apply properties. That property, shifting property, time shifting property and linearity property. Right? For that purpose, first of all, I want to write the signal, complete signal in terms of unit step function. So Laplace transform of amplitude is A is there. Right? And this constant amplitude is defined from minus t by 2. So that's why I am writing like this, u of t plus t by 2. And this is defined up to plus t by 2. So minus u of t minus t by 2. This is one method using shifting properties. Right? Now directly I am writing now, Laplace transform of u of t is 1 by s. Right? And Laplace transform of u of t minus t naught is e to the power of minus st naught into 1 by s. From this equation, just I want to apply this equation here. So from that equation directly I am writing now, A is constant as it is. Laplace transform of u of t plus t by 2. So from this one, minus t minus 2 means e to the power of s t by 2 minus Laplace transform of u of t minus t by 2. So by s is there, and e to the power of minus st by 2 by s. Right? Now finally what is answer? A by s, constant amplitude by s into e to the power of st by 2 minus e to the power of minus st by 2. So this gives the Laplace transform of rectangular function. Now I want to find this Laplace transform of rectangular function from this equation here. Right? From the basic Laplace transform formula. Laplace transform of f of t is, the equation explains integration is from minus infinity to plus infinity f of t into e to the power of minus st dt. Then I am taking this equation. See, less than the minus t by 2, this function is not defined. So this is equal to, integration is from, in which limits it is defined? Minus t by 2 to plus t by 2. Apply those limits here. Minus t by 2 to plus t by 2. F of t function is a into e to the power of minus st dt. Here a is constant, so take it outside. Then apply integration of e to the power of minus st. Integration of e to the power of ax into dx is e to the power of ax by a. From that, here directly I am writing e to the power of minus st by minus s. Limits are from minus t by 2 to plus t by 2. Then substitute higher limit and lower limit. Then becomes a into, higher limit is substituted here, e to the power of minus st by 2 minus, lower limit is substituted in this, it becomes e to the power of plus st by 2 by minus s. So take minus in numerator, then it becomes a by s into e to the power of st by 2 minus e to the power of minus st by 2. So finally it gives the same answer, a by s e to the power of st by 2 minus e to the power of minus st by 2. So here I have applied here one shifting property and linearity property, and here from the basic Laplace transform formula. So we can use different procedures, that is depends on the application, right? If you want direct answer, then we have to apply the shifting property, but for that purpose we want this analysis. First of all, you should know how to write rectangular function in terms of step function, right? Later we can apply the Laplace transform, right? If suppose this is not required for the basic Laplace transform equation, for this purpose just you have to write the complete function in terms of functional representation, then apply the Laplace transform. These are the different methods and different techniques to find the Laplace transform of the given signal. So please take this now.